is Playwright, actually? So Playwright is a browser automation library. It lets you do many things with a browser that you would usually do with your hands. Like you can open a browser, you can open pages, you can navigate pages somewhere. And actually with Playwright, you can do many more than this because you can evaluate scripts and you have a lot of superpowers with Playwright API. And you can also write scripts and run them in a reproducible and reliable manner. But rather than actually talking about this, let me just briefly show you what Playwright is so that we are actually on the same page. So for this, I will actually switch to my terminal. I hope it is big enough for everybody. And now I am a JavaScript developer. I am mostly fluent with JavaScript. So I will show you the JavaScript version of Playwright. And I will start from scratch. So this is just a fresh catalog. And the first thing I do, I initialize it as a Node.js program. Second thing I do npm install Playwright here. Sorry, this webinar windows here that are over my view. Okay. And once I install it, doesn't take much actually, and this is just a regular Node.js library. And as it got installed, I'm ready to go coding right away. Actually, I want to use a new fancy Node modules API so that it's more beautiful. So first thing I do is I will just straight ahead require 3 browsers that Playwright gives to me. Now, in Playwright, we control all the browsers with the same API, and I will demonstrate this to you right away. So I will just iterate over these browsers. And what can I do with a browser? Well, first thing I can launch it, right? Now, once I have a browser in hands, I can actually open a page there. Well, page could be navigated. And I will navigate to our Playwright website. And well, I'll just take a screenshot with it. And I'll save this screenshot to something like this. It's a PNG screenshot. And the last thing I shouldn't forget to do is to close the browser. Okay, so this is it. These are just 11 lines of code. It took me a minute to type it in. But by default, everything will be in a headless, so I won't see this program work. And for me to actually track some progress, I will do some debugging output. Awesome. Let's run it and make sure that it runs. Okay, so it's running Chromium, now WebKit, and Firefox. Okay, done. Let me clean my terminal window and let's see what is in my folder now. So now we have these 3 screenshots for Chromium, WebKit, and Firefox here. Let's look into the screenshots and make sure that these are real. Now here top of the window, you can see this, the name of the screenshot, and I can actually scroll through them. And as I scroll through them, you might see that there are certain differences in the way how the text is actually rendered. And this is actually because browsers render text differently, and this is actually a huge reason to test your websites in different browsers. Okay, so this makes it for my demo. It's my demo time. So what did we just see? So this is the snippet I had, and this is a JavaScript snippet, right? It's all in JavaScript world. Now, however, Playwright is also available to you in Python, and you will have exactly the same experience in Python. You just install Playwright there with pip, which is Python package manager, and this is the same script snippet written in Python, pretty much the same. And now also, since recently we released official Java support, so Playwright is available in Maven as a dependency. You can require it, and you can do Java automations as you would do with Java. So Java is a little bit more verbose, but you would expect this, I guess. Okay, so Playwright is certainly not the first and not even the second browser automation library out there. Now, why Playwright? And to answer this question, I will actually use the following trick. So we came up with these 6 beautiful adjectives that we think describe Playwright really nicely, which is, dependable, efficient, capable, ubiquitous, delightful, and lively. But these words by themselves don't mean much. So we'll have 6 acts per each adjective. And in each act, I will throw this adjective into you, and we will discuss why we think that Playwright is actually this good, and sometimes why no other browser automation solution is equally good. Okay, so with this, let me go straight ahead into the first act, which is Playwright being dependable. Okay, so what does it mean to be dependable? Well, for us, it means the following 3 things. So first, we have our GitHub repository, and anyone is free to come over and file any issue with a question or with a recommendation or whatever to our GitHub repository. And in the less than 48 hours, we will actually triage your issue. We will read what you wrote to us. And we take this very seriously. Usually we respond faster than 48 hours, but sometimes there are, weekends and holidays. So we have this small lag for us to be slow a little bit. So this is first. Second, once you file something into us, we actually act upon it, which means we take an effort to fix it. And over the year of Playwright existence, it's a little bit more than a year, we already fixed more than 1,600 issues that were filed into us. And last but not least is that we take full responsibility into what we do. And this probably requires more explanation. And to explain this, I will actually give you this hypothetical example, which is in fact not hypothetical. This is a real issue filed back in 2017 to Puppeteer repository. And someone wanted to know how to download a file in Puppeteer. And turned out that this was a fairly popular issue. More than 100 people, took the effort to Google this and, read the whole discussion and upvote this feature request. So let's now consider what would it take a cross-browser automation library to implement this feature. Now, it all would start with a very foundational layer with the browser engineering. And we have 3 browser engines as of today. First, we would need to do some work in Chromium to support the Downloads API there. And while doing so in Chromium, we actually make sure that Google Chrome, the new Microsoft Edge, the Opera, and all other Chromium-based browsers now have this functionality available. After that, we should do the same thing with WebKit, which is, which brings us Safari and mobile Safari. And mobile Safari is very important because this is what you actually run on your iPhone. And finally, which is the third bullet, we have to do the development in Gecko land, which is Firefox development or Mozilla Firefox. Now, at this layer, at the browser engineering layer, we are actually facing with the different operating systems. So we have to, interact with the OS-specific APIs. Okay, so this was the first layer, browser engineering. Now there is the second one. So once we have all the browsers here that expose the download API in browser-specific terms through their relevant remote debugging protocols, we have to have a unification layer. And in Playwright land, this would be a Playwright driver. In WebDriver land, for example, this would be a WebDriver API. But the idea is the same. We want to unify all the browsers under the same umbrella. And finally, once we unified all of these browsers under the same API, we want to expose these capabilities in our supported languages. Now in Playwright, we have 4 of them, but in each language, you have to come up with the idiomatic API, in our case, to control downloads. Okay, so in some average cross-browser automation solution, this work, for example, in WebDriver, this would take roughly 8 teams to do all the required effort. Now in Playwright, we are browser engineers with a lot of expertise in this field. It's just one team that does all the work. And this makes all the difference. Because, for example, in WebDriver world, the 8 teams have a lot of synchronization points between each other. And this naturally results in a responsibility blur. Like if something doesn't work, who is responsible for this? We need to go and figure. And this, as a result, has a huge feedback loop. So the time before you actually file the issue to the repository and you get some results, something implemented, it might be months, multiple months, or even years. So it's huge. Well, in case of Playwright, in our case, this is just one team. We are responsible for everything. If something doesn't work, it's our fault, and we will fix it. And since we have just single, like the same team is doing everything and developing everything, we have a really short and tiny feedback loop. It's usually weeks and sometimes even days. And we think it's really important. Now, so actually we follow this kind of workflow with many different APIs. So the downloads API that we had as an example here is implemented like this in Playwright. Screencast API, another example. Then drag and drop. So drag and drop, we just implemented, and this is common in the upcoming release in 1.11 in Playwright. Clipboard API, Joel is actually right now working on support. Browser level cookies, browser context. We have many examples that we successfully exercise this workflow to support the required features. Okay, so recap. Playwright is dependable because we triage and we read everything you write to us. We fix issues, and we have all the leverage to fix whatever request you have because we are in full control of what we do. Awesome. So this was the first adjective, and we're doing good so far. And we are moving on to act number 2, Playwright being efficient. Okay. Here, let's actually start with some terminology. So what does it even mean to be efficient? And actually, you might say that for browser automation, being efficient means, to run your test as fast as possible. And you wouldn't be wrong, you would be actually right, and this is called latency, right? But web automation has actually more costs related to it. Latency is one of them, of course, but also we want to spend as less CPU as possible. And this way, we will be able to work faster and more optimally in the clouds. And last, but actually most important, is that flakiness is a huge hitting factor for the automation. And this is because if some test fails, you usually need to retry it over and over again. You have to reset up your testing environment just to make sure, is this a regression, is this badly broken, or is it just flaking under refit? Now, in Playwright, we have a few tricks to actually mitigate these costs. And I'll quickly go over them with you. So trick number 1 is browser context. And browser context is a huge concept. It's really important and super powerful, but it's actually super simple to understand. No problem. So there is a rule of thumb. And rule of thumb is that you never, ever restart the browser. So restarting browser is slow. It takes more than 100 milliseconds, sometimes even more, and it consumes a lot of resources, both CPU resources and memory overhead. It's huge. Now, instead of restarting the browser, what we want to do is to create browser contexts. Now, browser contexts give you the same isolation as a browser process would do, but they are crazy fast to instantiate. They're actually equally fast to close and to destruct, and they have super low, like negligible, tiny memory overhead. So you can create as many of them as you wish. So let me illustrate. So you can think of a browser context as a box. And for example, here on the left, we have a box where I'm logged in my GitHub account. I'm logged in my Hacker News account. So all the cookies and all the storage is actually in this box. Now I can create a second box, and in this box, I'm actually not logged in GitHub. And this is because there's a huge isolation between these things. They do not overlap, and they only share the browser instance. So these are browser contexts. Now, if you look at the code, like what does it take to create a browser context? Turns out that once you launch a browser, it's really simple. You can just have a loop, and you can create these browser contexts in a loop, open pages inside this browser context, navigate them, and the only thing you should not forget to do is to close them. And these all operations are pretty much instant. Okay, so next trick is called auto-waiting. And for this, I want to tell you a story. Say, for example, I am a fellow web developer and I'm doing a web automation with some other browser automation tool, not Playwright, something else. And in my browser automation, I go and fill in email field, then I move on and fill password field, like all works as good. Then I hover over the submit button, I click it, and I miss. Now, I missed this click because the button actually was disabled. Now let me show you like what would look in the code. So this is my form filling code, and I, as a responsible developer, actually fixed it. Look, so turns out this is actually not a fix, because 1 second is a time which is very artificial. Time doesn't exist in heaven, and so it actually doesn't exist in the cloud. My virtual machine could be deprioritized during the script execution, so the web page didn't have enough time for the button to enable. You know, maybe my website is sending a fetch request to make sure there's some validations and whatever, and after the fetch request returns, it enables the button. Now, this only results in more flakiness, and this actually adds a lot of costs to my browser automation. Okay, so this is bad, and it's really unclear how do I fix this. I can write, more sophisticated code here, but let me introduce you to Playwright auto-waiting. So if I were to write this automation in Playwright, and I say, hey, Playwright, go click this submit button, Playwright will actually wait for the button until it is enabled. And once it is enabled, you will then click it, and the click will succeed. Now, in Playwright, form filling is just that simple. You navigate to the form, you fill all the fields one by one, and you're done. You don't have to care about anything else. Playwright will make sure that all of these interactions with the page are actually working. So how does it work? Now, for any type of interaction that Playwright has, we actually run a bunch of checks, and we make sure that all of these checks are working. Now, side note, in the top right corner of this slide, you see a QR code. You can scan this QR code, and it will bring you to the documentation where we explain in details what kind of checks we run, and you can all explore it. But for now, let me just go over the click, because we just saw how clicks working. So every time you ask Playwright to click something, Playwright will do the following. So first, it will check that the element is actually attached. Second, we would make sure that the element is actually visible, which is important. Third, and this is actually an interesting one, we will make sure that element is stable. And this means that it's not being animated. It's not shaking, it's not running anywhere, because you can miss, and usually you're not supposed to click moving elements in the web. Fourth, we should make sure that the element actually receives events. And last but not least, and very important, we should check that the button is actually enabled. Okay, so this was auto-waiting, and this is why we think, in summary, Playwright is efficient, because of these two cornerstone features. a lot of your browser automations are way more reliable and fast with Playwright than anywhere else. Moving on. And the next adjective is scalable. Sorry. So in this act, we'll have a slightly different structure. In previous two acts, we are diving deep into the details. Here we will have just a gallery of different features that Playwright have. And later on, you can rewind the presentation and focus on whatever feature you find most interesting. Now, on any slide, we will have a QR code with the feature. You can scan this QR code and it will bring you to our documentation where you can see examples, read details and so on. So first feature is device emulation. And turns out device emulation is actually a bliss in Playwright. So it just takes 2 lines. So first you get these devices object from the Playwright. And once you have it, you can use it to create a new context in Playwright. Now, Playwright emulation actually is very much trustworthy. We emulate user agent, emulate device properties, screen properties, DPI, landscape emulation, touch support, and so on. So you actually can trust this emulation. But I have to say one important thing here. So in this example, we are emulating iPhone. So iPhone has Safari. Safari is WebKit. So it is very important that I actually take and launch WebKit here. So this is device emulation in Playwright. Moving on. Next up is geolocation and permission. And well, as usual, in Playwright, you can customize context and create it with certain geolocation in mind. For example, here we are opening up a new context, and this context is somewhere in London. But once we have geolocation, we actually also should make sure that all pages have permission to query for this geolocation. And for this, we actually add permissions here. Now, actually, we will see this pattern over and over again when in Playwright, to configure something, you go and create a new context with certain properties. And this is very important. And this is why. Like in case of geolocation, all the pages here will share this. And by this, I mean that, for example, sometimes page does window open and a new pop-up emerges. Now, this new pop-up will be sure that it is actually in London as well, because both of these pages are in the same context. And actually, the page cannot escape its browser context. Okay, so now once we actually create a context with the geolocation, later on, if we wish so, we can change the geolocation to some other place in the world. Next up, video recording. And in the first demo, I showed you that it is actually very easy to record, to take a screenshot. Well, it is equally easy to record the video recording. And this is, again, a context option. And this context option means that you will get a video recording of all the pages inside the context. Even if the context opens a new pop-up, then you will have a video of the new pop-up from the very first frame. You will not miss anything. It all just works, and the videos are saved in the directory you pass it. And of course, you can customize it. Okay, next up, network. So if you've been working with some WebDriver-based solutions, you might experience certain pain points with the network monitoring. Well, in Playwright, we just give you network as it is. You can subscribe just for the request event on the page, and you will get notifications of all the web requests that the page is actually sending. Now, not only this, actually, you can get the same notifications for all the WebSockets that the page creates. And once you have a WebSocket object in hand, you can also subscribe to the frames received and frames sent events in the WebSocket, so you can inspect everything there. So this is very cool, and I don't know of any other browser automation solution that has WebSocket inspection, for example. Next up, request interception. So request interception is this feature that you can not only monitor the network traffic, but you can also change it and fake it. So here we just subscribe to all the image requests, and this is a very naive way to detect images, but worthy for the demo. And for each image, I will just abort this request right away. So this is a very simplistic image blocker. And this is cool, but actually we can do nicer than this because we have the same API and the context level. And if you want to use this API to, for example, mock certain API requests, you can do so. And with the context level request interception, you can also mock this API for all the pop-ups and all the pages that will exist in this context. So I think that actually in real life, you only care about the context level request interception. Next up, downloads. We already talked about downloads briefly when we talked about what it takes to implement, cross-browser web automation. Now, this is what downloads look like in JavaScript world in Playwright. This is just a download event. You can subscribe to it, and once you have the download object, you can explore it, and do things with the downloads. Okay, this is a really cool one. These are selectors support. And unlike in WebDriver, selectors in Playwright are all string-based, and this lets you do many cool things with it. Let me show you briefly what are these. Now, first thing first, if you're old-fashioned and you prefer simple CSS selectors, you can just use CSS selectors here, not embedding this. However, you can prefix your selector with XPath equals, and this will give you an XPath. Now, this XPath equals is actually called a selector engine in Playwright, and we have a bunch of them built in. And the other one interesting is called text selector. So this one, for example, gives you a simple way to select an element which is case insensitive and substring matching for the login text on the page. Now, there is a common problem that there is no nth match in CSS, but we extended CSS a little. So we have a pseudo class called nth match. So now you can select the third by button to actually click it. Okay, we also have these super cool ones. These are called layout selectors. And this is again our extension of CSS. We have a few pseudo classes in CSS, such as right off, left off, above, below, and near, that you can use to show the visual relations, the layout relation between elements. So for example, here we have div, which is right off to something that has a name as a text name. And finally, we have this composition combinator, which is 2 angle brackets. So you can actually mix and match these CSS engine selectors, not CSS, selector engines together. For example, I can use XPath to select a form, and then inside this form, I can use a text engine to select something with a submit text in it. And these are CSS selectors, so selector engines. Next up, assertions. So we're talking about web automations, and web testing is a huge part of web automation. And web testing is impossible without assertions. Now, Playwright has a bunch of APIs to support the assertions. It's really easy to query text from the page. Post text content and the inner text are there. Element attributes, if you care about them, are accessible very fast. You can check form state. For example, you can check if something is checked or not. And finally, you can check the visibility state of certain elements. And this is a very common use case, in fact, in our web tests. Okay, and this is the last slide of this gallery. This is a browser support, or specifically the new Microsoft Edge support. Now, in Playwright, we have this channels API, and by using different channels, you can teach Playwright to launch different browser instances. Now, with the channel inside the Chromium browser, you can use Chrome Stable, Chrome Beta, or MS Edge browsers, for example, to launch them, and Playwright will use this browser instead of the built-in Chromium to run your automations. Now, please keep in mind that this is probably the only API here that is on the browser level and not on the context level, because this is purely about the browser instance that we launch in the very first step. Okay, so actually we have much more features than this. So we have the most noteworthy one is actually the built-in Shadow DOM piercing. And we know that Shadow DOM deals a lot of troubles to us web testers. And all the smart selectors that I showed you a few slides back are actually working seamlessly with Shadow DOM. everybody loves this. Next one that I want to mention is custom selector engines. So you can actually extend Playwright and teach it to work with your React application. And you can say, for example, playwright.click or page.click React equals, then there is your form and shape of React selector that you can come up. And there is even a third-party library that already got this for React. Okay, you can emulate many more things, time zone local. There is a per context HTTP proxy, which certain groups of our clients find very useful. We expose workers, service workers, give you console, dialogues, file uploads, element handles, and many, many more things, actually. Now, we not only have all of these features, but we actually also make sure that they work. And we ourselves are fans of automated testing. And here on the slide, I just listed you the names, just the names of the test machines. And each of these test machines runs thousands of tests, automated tests that we run on every commit. So this way we can make sure that all our features work across the universe in all the languages, in all the operating systems, and in all the browsers. Which naturally brings us to Playwright being ubiquitous. So Playwright is very powerful. There are many things in there. So we actually think that there is no other browser automation solution that has this level of interoperability between different environments. And let me show you one of the reasons. Here is WebKit browser availability across the different operating systems. Now, if you look here, for example, and you have a Windows machine, you can see that there is no way you can check or test your website on WebKit on Windows. Your best option would be go and find some Mac somewhere on some iPhone. If you're on Linux, or even if you're on Mac, and yes, you have Safari there, there is no way you can run your tests in a headless manner. Now, it does help that Playwright has a bunch of browser engineers in the team. So what we did is we actually came up with a Playwright WebKit embedder. And this is a browser, which is a fully functional browser that uses WebKit, and that is available for you everywhere. So we just fill the gaps. You can use it on Windows, you can use it on Mac, you can use it on Linux, and it works in both headed and headless manner. Now, okay, you might not care about all this browser automation APIs and everything, but you can just use this right away. And let me actually show you how. So I'm here, and I will use this thing that is called Playwright CLI. And I can just use Playwright CLI to launch Playwright WebKit browser as it is. So here I am, and I can, just navigate to, for example, my personal website. Here I am, and I can make sure that it is reasonable and that it is working. And this wasn't possible before because there was no WebKit on Windows. Now I can just go and manually check things if I want. So, okay. How do I switch back? Here I am. So with this, Playwright is actually working the same way in all the browsers, in all the operating systems, in all the popular languages, and we actually make sure to test it across all of these combinations. And these are all the desktop setups. Now, you might say, okay, this is good. What about clouds? Like, does it work in the clouds? Well, of course it does. You can pick any CI/CD of your choice, be it GitHub Actions, Azure Pipelines, AWS, GCP, Circle CI, whatever. You can easily launch your browser automations with Playwright there, no trouble. If you are a Docker guy, we publish a bunch of containers like Playwright and Playwright Java, and you can use these containers in your, for example, in Circle CI as a base image. Now, there is a bunch of third-party integrations, and we have many of them coming, and these are basically services that use Playwright one way or another. And interestingly, some of these services are now providing Selenium Hub-like functionality to scale your Playwright tests. Now, this brings us actually to the WebDriver topic, and Playwright actually loves WebDriver. And the reason is because we share some common heritage. Let me give you some historical context. So this is a very schematic representation of Chromium browser, and we can see that internally we have the Chrome DevTools protocol project. Now, somewhere around 2013, we were involved in a project that was moving Chrome driver implementation, which is a web driver implementation for Chrome, over to Chrome DevTools protocol. Now, WebDriver API is not vast, so Chrome driver was just naturally using a small portion of Chrome DevTools protocol. Now, Playwright, on the other hand, uses the full power of Chrome DevTools protocol, just because you want to implement all these numerous features that we were talking about, a few slides before. Now, here you can see that actually Playwright and Chrome driver share the same bit of technical stack, which is a Chrome DevTools protocol, which lets us reuse the WebDriver-based infrastructure in an interesting way. So say, for example, you have some WebDriver grid somewhere on your on-premise setup. And chances are high that you already exposed Chrome DevTools protocol from this WebDriver grid, or Selenium Hub, whatever. Now, since recently, we introduced a new API, which is Connect over CDP for Chromium, that lets you connect Playwright to this WebDriver infrastructure. And this way, you can have basically best of the both worlds. You can use your WebDriver infrastructure, you already built it and invested in it, and you can drive it with your Playwright and with all our fancy, cool APIs and reliability. Now, if you're interested about this more, you can go scan this QR code, and there is some documentation that explains how to use it. Okay, so this was ubiquitous, and we are moving on to the next act, which is Playwright being delightful. Okay, so here I took the liberty to extend delightful to delightful authoring and debugging. And I will actually just demo a few cool tools that we have in Playwright. So let me get back to my terminal here. And I already showed you this Playwright CLI tool, and we have a lot of options here. And I will start with actually the code gen. So code gen is our way to generate code without actually writing any code. And it has a bunch of options as well, and we might touch some of them later on. But the one I want to start with is this output. So I want to save my snippet to, for example, GHS. Okay, let's hit enter and see what it gives us. So let me resize some windows here so that we can see everything. And there's, okay, here I am. So what this command gave me is two windows. And this one on the left is pretty familiar. This is just a Chromium browser. But this one on the right is a Playwright inspector. And this is the interesting part here. Now we can see that Playwright inspector already generated some basic scaffolding for me. And it's actually recording. So let's see how this recording works. So I can just go to, my browser window and navigate the page to the, for example, to our website. And what I see here is that it actually generated me my navigation in a code, right? Now, actually, side note, I'm a JavaScript guy, so I'm showing this JavaScript here. But actually, if you are a Java guy or Python guy, well, you can have all the same thing in Python, Java, or whatever. You have even a cool async version of Python, which is a new thing. But since I know JavaScript, I'll stick with JavaScript for the purpose of this demo. Okay, so Playwright, while actually recording this, it gives me this interesting feedback when I try to interact with the page. You see, it hovers and shows this red rectangle. Now, this rectangle is the element that I would interact if I were to click now my mouse. And below, we can see the selector that Playwright actually generates to record the section. Now, for example, I can click this 205 number, but this wouldn't make for a reliable browser automation. So I can just click on the issues right here, and I will do so. Now here, this is actually interesting. Look, it not only recorded my click, but it also noticed that the page did a navigation. So it recorded the navigation and associated them with each other. So this is a very reliable way to record things here. Okay, let me go on, and I'll just type some things here. So I'll search for something. There's nothing. I'll click a button here. I'll click here. You know, just basic stuff. And this is the snippet. So actually, I can just stop recording now, right now. And this snippet is available in all the languages, which is pretty cool. Okay, so it is all recorded. It all works. So let me just close my automation here, and I can, you know, go and look at my automation here. Now, actually, you know what? I don't like this last step. It's too much, and this is about right. This is cool. Let's try and run this with Node. This is just a regular Node.js program. So it runs and navigates, and it all works, you know, seamlessly. Now this is Playwright. So I can just use any browser, and it will run the same browser automation for me. Okay, and you know, if it was Firefox, you saw it clearly, and it was working just like this. Okay, so now let me show you something else. So I don't want these two calls here. And now I will launch this script, but with this pwdebug environment variable beforehand. Now, when I do so, it launches the script for me. And in Playwright Inspector, I can say that this is actually paused on the first go-to, and I can step over all these comments, and it will step over, and it will pause on the next section. Now, this is click, and this is actually interesting because for click, it will show me where it will click, and it shows me the element with this blue rectangle and the click point with this red dot. Let me run a few more things here. I'll show you even more things. This webinar software is a little bit in my way. Okay. So now, for example, we have this fill command somewhere here. This is a log of all the actions that Playwright did. And we can actually hover over these two small icons. Like look on the left on the blue rectangle here. This is the state before fill, and this is the state after fill. So I can see on the state of the page before and after the action. And if I hover over the click, I will see where it will click or where it did click, and how much time it actually took as well. Now, while I'm here, I can actually open DevTools. And I can use my Elements panel and do certain selectors. Or I can use console. And console, we give you this handy Playwright object where you can just exercise, this is Playwright selectors, and you can use it live right away. Or if you don't want any of this, there is an Explore button that you can click, and it will give you this hover that you can use to explore selectors. And once you click, this is the selector. You can copy it and change your browser automation later on. Okay, so let me actually continue. Oh, yeah, I'll close my browser automation here. So this was cool, and it was all headful. But I want to show you that actually it all works headless, just the same way. So now I'll launch it, and it runs. And once the automation actually completes, it will return control to me in my terminal. Now, I say that for some reason this doesn't happen, which is a perfect opportunity for me to debug this. So how do I debug this kind of an issue? I can run this with a PW API. This is a debug environment variable, which has this notion. This is a default Node.js debugging strategy, by the way. and you can launch it, and you will see all the calls that Playwright is doing, and you can see that it actually everything was successful. Yeah, I can see it. So the click succeeded, and then even network idle fired. So the reason it actually hangs for me is that I forgot to remove these two calls. Okay, so if I'm calling this right now, I can see it all completes successfully, and I'm back in my terminal. Okay, so this is cool, and this was really fun to do. But I want to show you something more fun, actually my favorite demo of the day. And for this, imagine the following situation. Like say you have a test, for example, and usually when you have a test, you have to log in with your test credentials in the very beginning of the test, which might be the problem, might not be the problem in itself. But once you have thousands and thousands of such tests, it becomes time consuming. Like every test spends like initial 5 seconds to do the same repetitive work. And even though it is fast and reliable with Playwright otherwise, it still consumes your time. So actually, it turns out you can reuse these credential information. And to demonstrate this, I will show you another command. So we'll have this open command, and open, let me show you, has this fancy flag which is called save storage. I will use it. I will say, okay, save storage to JSON, and I will navigate to my Hacker News website. And important thing here, it's not logged in. You see, there's a login button. So I will log in right away with my credentials. And here I am, a solution cap logged in. Cool. I'll exit this. Now, it promised me to save something into HNJSON. And we do have this file now here. Now, I will not show you the contents of this file, but it's basically cookies and local storage information. Now I can reuse this, and I want to quickly generate a snippet for you that uses this credentials information to seamlessly log in browser for me. And for this, I will use actually the code gen, like that you already saw, that has a fancy load storage flag. Now, once I launch it, it navigates to the Hacker News website, and you see I'm logged in right away. And if you go here to the snippet, we can see that this snippet is actually, has this one line, storage state, Hacker News JSON, when we create a new context. Now, I forgot to save the output parameter, so I'll just, save the snippet, and I'll say hackernews.js, and I'll paste it here. I'll remove this. This is it, and I'll, run it. And this is my regular Node.js, and it is reusing my storage information as easy as this. Now, even if your website is actually not doing anything browser specific for the login workflow, then I should be able to, reuse this browser storage information across the browsers. So let's do this for Firefox. And this is Firefox, and yeah, well, you see, I'm logged in. So this is a success. Okay, very cool. This was my delightful demo. A small recap. So we saw the code gen tool, we saw the node snippets, we saw the Playwright $, and last but not least, we saw the state reuse, how we can reuse the credentials between the automations, generate them easily, and then just populate our context with them. Okay, which brings us to our last sixth act here, which is Playwright is lively. And this is actually a short one. So what we mean here is that Playwright is going under very active development. Over the last year, I think, we have more than 2,500 commits landed, which is a lot by any standards. And as we told before, we have more than 1,600 closed issues, which is cool. We started with that 5 people, the core team, but we now, I think we are now 7 people. and we are still growing and we are still hiring. So this is a very much developing project and development team. And we are keeping experimenting and we are expanding our horizons. And by this, I mean that we are actually running a few experiments that we are likely to release in some future. First one is experimental Electron.js support. So if you have Electron application, you can use Playwright to easily test it. And actually, you can do whatever. It's a very neat API. If you want to learn more, go scan QR code and you'll see our documentation. And even more impressive is that we have an experimental Android debugging support. And this lets you use a real Android and launch browser inside this Android, and then use Playwright API to debug or to control this launch browser inside the Android. Okay, so this was it. It was my last slide. Conclusion. So if there is some conclusion that one takeaway from this presentation is that web automation can actually be fun, and we think it is actually real fun. And it is actually fun if you use playwright.dev. This is our website. Please head it over. And yeah, so this is it. My name is Andrei.